Hi everyone. So it's me, Gary again, and today we are going to start our second seminar. So let's start it. So this is today's outline. So first we are going to talk about more details of our seminars and assignments. So for example, how to submit the assignments on Athena and what to submit, and also how to ask for help. And the second thing is we are going to talk about term paper shortly. The third thing is we are going to help you review some concepts of statistics and probability that you learned in a lecture. And the fourth thing is we are going to introduce you some coding further in Stata. And the fifth thing is we are going to talk about law of large numbers and also central limit theorem, which you will need to answer in your assignment 1. And the sixth thing is how to standardize variables. And the seventh thing is like more codings about standardization. So first, it's about why we hold these seminars. So basically, a seminar is to give you give you answers about assignments and also teach you how to solve the problems that may appear in the assignments or in the term paper, and also help you review some basic statistical or econometric concepts, and help you prepare for your term paper as well. Yes. And for assignments, so to hand in the assignments 1 to 5, so you need to hand in both PDF file and also your do file. And out of 5 assignments, the last one, assignment 5, is individual, because we just want to make sure that every person in this class have the ability to solve the statistical questions and also have the basic ability of using Stata. And one thing that you might need to take notice is that the quality of your assignments will be taken into account for your grades in this course. So to hand in assignments in Athena, so as you can see in the monitor, so there is some naming conventions. So you need to specify which assignment it is and what is your group, and also the last names of the group members. And for a term paper, so there are some deadlines that you might need to keep in mind. So the deadline for the preliminary version is on May 13th at 4 p.m. And the deadline for the final version is on June 7th at midnight. So for term paper, you need to upload a PDF file, a do file, and the dataset that you use in your term paper. And in the normal situation, so the preliminary version needs to be presented in the last seminar, May 15, which is mandatory. In the presentation, you have a possibility to get the advice from us. But now since during the coronavirus, so we are not sure about how to do the presentation yet. Yeah, so we will talk about how to solve this problem later. So yeah, so just a reminder, you can start to think about the topics of your term paper. So it will make everything more smooth if you started earlier. So now we are going to review some concepts that you already learned in the lecture. So first, there are two concepts. One is called random variable, and the other is called probability. First, random variable means a numerical summary of a random outcome whose values cannot be determined with certainty. So basically, you can understand it as something that is not certain, or something that has the result that cannot be determined. For example, when you flip a coin, you cannot be sure that the result must be a head or a tail. As a result, we can call the result of flipping a coin a random variable. Next is the probability. So the probability means the likelihood that an event will happen. Formally, as shown in the slide, so it means the proportion of times an outcome occurs as the number of trials n converge to infinity. So let me use the example of flipping the coin again. So it means that, for example, if you throw a coin 1 million times, the probability 1.5 that you are quite familiar with means out of these 1 million times, there will be 500,000 times that the coin will show either head or tail. So there is a reminder, which is also quite straightforward, is that the relative frequency might not coincide with this probability if n is small. So which means that, for example, if now you only throw a coin once. So it's quite easily to see that either the probability of head is 1, the probability of tail is 0, or the probability of head is 0, the probability of head is 1. So actually you can see that 0 and 1 is really different from 1.5, which is the true relative frequency of the result of flipping a coin. Next, we are going to introduce two concepts. So first is called probability distribution function, and the other is called cumulative distribution function. So the first one, probability distribution function, is the list of all possible values of the random variable x and the probability that a specific value x will occur. So for example, when you throw the dice, the probability of when you throw a dice once, so the probability of showing 1 is 1/6. The probability of 2 is 1/6 as well. And then 3, 4, 5, 6 are all 1/6. So this is one example of probability distribution function. And cumulative distribution function is the probability that the random variable x takes on the value less or equal to some particular value. So if we use the example of throwing a dice once, so which means that, for example, the probability of x is smaller or equal to 3 is 1.5, because the probability of showing 1 is 1/6, the probability of showing 2 is 1/6, and the probability of showing 3 is 1/6 as well. So when you add 3 of 1/6 together, it becomes 1.5. So what we just mentioned is the case of only one random variable. For example, throw a dice once or flip a coin once. And now here come the case of two or more random variables. So the first one is joint distribution. So joint distribution is the probability that two random variables, say x and y, simultaneously take on the specific values, say x and y. So for example, you can think, you can understand it as, for example, the probability of if you throw a coin which shows head with throwing a dice which shows 1. And then marginal distribution of x is actually just simply the probability distribution of x averaging over information about y. So actually the marginal distribution is the same as the case of only one random variables. If we use the example of throwing a coin and dice at one time, so the marginal distribution of throwing a dice is just the probability of throwing a dice, and you don't care about throwing a coin at all. So this is these are joint distribution and marginal distribution. And then the third one is called conditional probability. So it's the probability that an event occurs conditional on another event also occurring. So which means that, for example, if what's the probability of a coin shows head under the condition that a dice shows 1. So if we formally state it, it means that the probability of both events occurs. So for example, here x equals small x means the coin shows head, and big Y equals small y means the dice shows 1. And then here is the dice shows 1 as well. So this is how we calculate conditional probability. And related to conditional probability, there is another concept called independence. So two random variables are said to be independently distributed if knowing the value of one of the variable provides no information about the other. So which means that it doesn't matter whether A event happens conditional on B events or not. So which means that no matter there is a conditional probability on B events, the probability of A is always the same. So as you see on the slides, so which means that here So the probability of x equals small x conditional on capital Y equals big Y is the same as the probability of just directly big X equals small x. So which means that under the condition of independence, the probability is the same as the marginal probability. So now there is an example. So you can see that there are two random variables. R means rain and C means commuting time. R equals 1 if it rains and R equals 0 otherwise. C equals 1 if the commuting time is long. C equals 0 if the commuting time is short. Therefore, we have 4 possible outcomes. And the table below describes the joint probabilities of 2 events. Note that they sum to 1. So now we have 6 questions. So the first one is the marginal probability for commuting time is short. And the second is marginal distribution of R. And the third one is marginal distribution of commuting time. And the fourth one and fifth one is about the conditional probability. And the sixth one is actually as well. So now let's start to do the exercises. So the first one, the marginal probability of C equals 0. So just like what we said, the marginal probability is the same as the probability of single events, regardless of other events. So which means that you don't need to care about whether it rains or not. So So you don't need to care about whether it rains or not, as long as the commuting time is short. So as a result, we can get the answer is 0.63 plus 0.07, which equals 0.7. So this is the first question, the answer for the first question. And then second question, the marginal probability, the marginal distribution of R. So we need to list out the probability for all the possible results of rain. And we know that, so R, raining takes 2 values. So it's either 0 or 1. So we need to list out the probability for both raining and not raining. So the probability of not raining It actually means the marginal probability of not raining. So it's actually similar as our first questions. So in this case, you don't need to care about whether the commuting time is long or short. The only thing that you need to focus on is not raining. So question 3 is similar. Equals 0. Oh, it's C. C equals 0 and R equals 0 plus P, C equals 0 and R equals 1. So it's actually the same as question 1. And for the probability of C equals 1 is the same way of solving it. Which equals 0.3. So there comes one thing that you might notice in calculating the marginal distribution. So you can see that the total sum of the marginal distribution needs to equal 1. So for example here, 0.73 plus 0.27 equals 1. And for in the question 3, 0.7 plus 0.3 is 1 as well. So this is the answer from 1 to 3. And then there's question 4. So the conditional probability of short commuting time, conditional on raining. So short commuting time, conditional on raining. So to calculate probability, we need to find out the probability of both events occurring, and then divide it by the um, probability of the conditional event occurs. So in this case, we need to first find out the probability of um, the commuting time is short and it rains, and then we need to find out the probability of raining. So actually, we can find it. We can find the answers of both two values in the question, and also from the calculation that we just did from question 1 to 3. So the first one is the probability of short commuting time with raining. So you can see that it's 0.07, and then divided by raining, which we just calculated, is 0.27. So we can see the answer is 0.259. And for question 5, so the conditional probability of long commuting time on not raining. So commuting time is long, conditional on not raining. So the first one is the probability of both the commuting time is long and it doesn't rain. So we can see that is 0.1. And then second, the probability of not raining. So we can see the answer is 0.73. So which equals to 0.137. For question 6, it's also the same technique. So now the things become the conditional probability when it rains, but conditional on the situation that the commuting time is short. So the probability of both it rains and the commuting time is short is 0.07. And then the probability of commuting time is short is 0.7. So the answer becomes 0.1. So this is the all the six exercises about a conditional probability. And now we go back to the slides. So now here come more concepts about statistics. So as you can see in the slides, there are 3 concepts. So the first one is population, the second one is sample, and the third one is random sample. So the population means the entire collection of entities. So it can be individuals, it can be firms, and it can be countries. So basically, you can think population as the things that you would like to observe or the thing that you would like to know about. And the second thing is sample. So when the whole population cannot be studied, one has to take a sample of entities from the population. So for example, if you want to know about the wage distribution of all the populations of Sweden, however, it's not that easy to ask every person in Sweden. It's not that easy to ask every person in Sweden about their wage. So as a result, you would like to choose some people to ask their wage, and then use these people that you interviewed to get some idea about the wage distribution in Sweden. So if we use a more professional language to say it, so it means we use the sample to make generalizations about population. So here comes a question, because you would like to use the sample to know about the population. So the sample should be representative to make generalizations about the population. So which means that the people that you try to interview about their wage should be representative about the whole Swedish population. So for example, you cannot intentionally pick the poor people or like all rich people in your interview. Otherwise, they are not representative of the wage distribution of Sweden. So here comes another concept, another related concept, which is random variable. So which means a subset of elements randomly chosen from the population. So which means that you just try to pick up the sample randomly. So which means that every individual in the population has an equal probability of being selected. And they should be independent of one another. So the population of, for example, me being selected and the population of another person being selected in the interview should be all the same. And the probability of me being selected and another person being selected in the interview should not be like they should not influence each other. So if I get elected, it should not affect the probability of another person being selected. So which means independence. So in other words, the random sample means that the subsets of elements should be randomly chosen and independently and identically distributed. So one thing that you need to keep in mind is that this is one of the keywords in this class, which is called independently and identically distributed. Actually, this is the foundation for everything that you would learn afterwards in econometrics. So now we are going to the data part. So let's start the teaching of data today. And from now on, I will use this script to show you how to execute some basic commands in Stata. So let's start it. So first, I would like to teach you about some general settings. So the first command is called clear all. So by executing clear all, you can clear all the memories in the starter to make starter restart. And the second is called set more off. So set more off is to show all outputs and do not stop when the output window is filled up. And the third one, I think is the most important one among these three commands, is to set working directory by inserting search path to your folder and store the data in the same folder. So to set your working directory by inserting search path, you should use cd command. And this is the search path. If you want to set your working directory in a 701 folder in document folder. So if you set this one, and you can see that now the starter set the working directory in 701. And one thing that you need to take notice is that you should make the slash to the left rather than the right. Otherwise, the starter cannot execute this command. So now, since we set our working directory and put the datasets in our working directory already, then now we need to import the datasets into starter. Since this working hours database is in DTA file, so to import it, we should type use working hours DTA clear. So you should remember to put double quotation mark on the dataset you would like to import, and clear means that to clear the past dataset. So you can see here we already import this dataset. And if you would like to take a look at this dataset, you can clear here, called data editor. And if you click it, you can see the contents of this dataset. So first, we would like to teach you the commands for creating variables. So it's called gen. So gen is the abbreviation for generate command. So for example, if you would like to generate a variable called variable1, which takes on the value 10, then you should write gen variable1 equal sign and then 10. So following this logic, if you would like to create another variable called variable2, that is twice as large plus 5, then you should type generate variable 2, which equals 2 times variable 1 plus 5. And now use the variable age from working hours dataset and create a new variable called age2 that is equal to age squared. Following this logic, then we should type generate age2 equals age squared And next is use the variable income from working hours and create a new variable called tax, which is 30% of the income. In the same spirit, then we should type generate income generate tax equals 0.3 times income. And for the number of children, it's the same. So generate number of children equals child 3 plus child 5 plus no, I typed it wrong. Child 5, child 13, and child 17. So since now we generate many variables, if now we would like to drop those variables, to delete those variables from the dataset, then we should use the drop command. So for example, now we would like to drop variable 1, variable 2, age square, tax, and numbers of children. If we would like to delete all the variables that we just created from the dataset, then we should use drop command. So we should type variable 1, variable 2, age square, tax, number of children. If we execute it, then we can delete them from the dataset. So now we are going to talk about a special variable called dummy variables. So a dummy variable, which is a variable that only takes value 0 and 1. So 0 means no, 1 means yes. So, and 0 means non-existence, and 1 means existence. So one very classic example is for gender. So typically, we usually have only 2 genders. So either male takes 0, and then female is 1, or male takes 1 and female takes 0. So now if we would like to create a dummy variable which called child below 5, so this variable will have value 0 if the individual has no children below 5, and if the individual have any children below the age of 5, then it will take the value 1. So to create this dummy variable, first we should create a variable named child below 5 that is equal to 0. And then we should use a replace command to replace value equals 1. If the individual have any children below the age of 5. So which means that replace child below 5 equals 1 if child 5 bigger than 0. So child 5 bigger than 0 means that the individual have more than 0 kids under the age of 5. So if we execute this command, you can see that the output window shows that there are 1,233 real changes made. So which implies that there are 1,233 individuals who have any children under the age of 5. So this is for dummy variables. And then now we are going to talk about eigen command. So the eigen command is to create new variables using functions. So the gen command is for creating variables as well. But if you want to create new variables by using functions, then you should put an e in front of gen. So for example, now you would like to compute the mean of income for observations with and without children under the age of 5. Then you should type eigen mean income ch5, so which means that the mean income of the observations with children under the age of 5. Now, since we have some restrictions in our computation, so we should specify the condition. So we use if to specify the condition. So if child below 5 equals 1. And to compute the income for the observations without children under the age of 5. So we should type mean income if child below 5 equals 0. So by this way, then we can compute the mean of income. And if you would like to summarize the variable means that we just created, then you should use the sum command. So sum stands for the abbreviation of summarize. So if you summarize it, then you can see that there are 1,233 individuals who have children under the age of 5, and the income and the mean of those people's income is 257, while there are 2,149 individuals who don't have any children under the age of 5, and their mean of income is 319. So there is one thing that you should take notice. So you should take notice that here should be the double equal sign rather than single equal sign. So the reason for this is that so the single equal sign is to use when you have to create new variables, but double equal sign means something already created and which can be stated as conditions. So if you only type single equal sign here in the condition, then the data will not recognize it. Conversely, if you type double equal sign in the generation command, the data will not recognize it as well. So this is one reminder that you should take notice. And then next, we are going to compute the sample standard deviation for the income of those individuals with and without children under the age of 5. Actually, this is similar with how we compute the mean as well, but just change the function. So it's the same as eigen standard error income for child under age of 5 equals SD function income. So this SD function stands for standard deviation. And then if child below 5 equals 1. And to summarize them, it's the same as what we did with mean. As you can see in the output window. And then the next part is, how about we have more than one condition? Then we need to use and or to connect our different conditions. So first, if I would like to compute the mean for all observations with age below 30 and any children below the age of 5, then we should write eigen mean income child 5 age 30 equals mean income if age below 30 and child below 5 equal 1. And if you would like to compute the mean of all individuals with age below 30 or any children below the age of 5, instead of using the and sign to connect it, you should use a straight line. And if we summarize them, you can see clearly from the output window that they are very different. And then the next part is actually, other than directly using the function command, you can also use the summary command, which will directly give you the summary of statistics of a variable. So for example, if I would like to get the summary statistics of income of households who have children whose age is below 5, then actually I can directly summarize income if child below 5 equals 1. So you can see here that, so the mean of the income, so the mean of the income of the individuals who have any children under the age of 5 is 257, which is actually the same of what we calculated above here. So the mean for the income of individuals who have any children under the age of 5 So after you summarize the statistics of, for example, income, uh, what if now you would like to use those statistics? Then you should type return list. Return list will um, help you temporarily store the statistics from the summary. And then you should use the command scalar to permanently store them in the variables that you created. So for example, if now you would like to store the mean of the income of individuals who have the children under the age of 5, then you should type scalar mean income children 5 equal r mean. And for the standard error, for the number of people, for the variation as well. So by doing this way, then you can successfully store the variables that summarized in the summary comment into some permanent variables. So now if we click return list, and then we execute this command, so which means that now the data will store the result from the R mean to mean inc ch5 and store the values in RSD here into SD inc ch5, and for the below two variables is similar. So why should we do this? Is because, for example, now if we would like to store the summary statistics of income of households who do not have any children below 5, so it's similar now. So if we summarize income, if children below 5 equals 0, and then we also use return list. So you can see that now the results in the R mean changes, since return list is just a temporary place to store the values after you use the summary command. So after you summarize different variables, you summarize income under different conditions, then now the return list will store different values. So before the Rn, for example, stores the value of 1233, but now Rn turns to store the value of 2149. So to prevent the value that's stored in return list changes because of your operation, then we should use scalar command to store those values. So it's actually the same technique, but just in different names. And now we are going to teach you how to compute the confidence interval. So to compute the confidence interval, first we need to find the standard errors. So to take the income with and without children below 5 as an example, so to find the standard errors for those variables, then we should type the standard errors of income of the income of individuals who have any children under the age of 5. Then we should type the standard deviation of income of individuals who have children below 5 divided by the number of the square root of number of people who have any children below 5. So this is how we calculate the standard errors. So we use the standard deviation of that variables and then divide it by the square root of the numbers of observations of that variables. Then we can construct a 95% confidence interval for the population mean. So to find the lower bound and upper bound for the confidence interval for those variables, we need to use means plus or minus 1.96 times standard errors for constructing a 95% confidence interval. So to do that, we use scalar command and then type mean income of children, income of individuals who have any children below 5 minus 1.96 times the standard error that we just created. And the upper bound is just to change the minus sign into plus sign. And to construct a 95% confidence interval for the individuals who don't have any children under the age of 5 is similar. So we just change the mean. And the standard error. So if we would like to display it, so we should use the display command. As you can see, the output window will show the confidence interval, 95 confidence interval that we created for both variables. So 95 confidence interval means that if you try to do the random sampling for 100 times, so out of these 100 times, there are 95 times that the true mean of the variables will locate between these intervals. So this is the meaning of confidence intervals. So if we would like to construct a 95% confidence interval for the means of income for the individuals who have any children under the age of 5, so we should type CI means. So we need to specify means of income. Like we would like to construct the 95% confidence interval for a means of income, and then specify the condition, which is for the individuals who have any children under the age of 5. And here is in a similar way, but just change the condition. So this is how we construct a 95% interval for the individuals who have or don't have children under the age of 5. How about now we would like to construct the confidence interval for difference between population means. So the above, where we would like to create is just to construct the 95% confidence interval for single variable. But now what we would like to compare the difference between population means. For example, now I would like to know the 95 confidence interval for the difference between the means of income of individuals who don't have any children under the age of 5, or who have any children under the age of 5. So to do it, now we should use different ways of calculating the standard error. So to do it, we should use scalar command to store our calculation, and then calculate the standard error for difference in mean, which equals square root of the variation of income of individuals who have any children under the age of 5 divided by the number of observations plus the variation of incomes of the individual who don't have any children under the age of 5 divided by their numbers of observation. So one thing you need to remember is that to calculate the standard error of difference in mean, the plus sign should be inside the square root. And then now we can create the confidence intervals for the difference in the mean of those two different types of people, their income. Mm. And then we will display them. So if you would like to put some comment before the values that you created, so we could use the double quotation mark to write them. So you could say that display the lower bound of the confidence interval is, and then the variable that we just create, and here is similar. And if we execute these comments, then you can see that the data will show that the lower bound of the confidence interval is 43.632469, and the upper bound of the confidence interval is 79.703716. So which means that if you do the sampling 100 times among this sample, then out of and 95 out of 100 times that the true difference of means of these uh, two types of people will be located between 43 plus 43.6 and 79 plus 79.7. So this is the first part of our data teaching. And then now we will go back to our slides. So another concept is called estimation. So by estimation, which means that we use the observed sample to give an estimate of an unknown population parameter. So just like the example, that we just said, if you want to know the wage distribution of the people in Sweden, then you would like to draw some random samples in the population to know about the true, for example, wage distribution of Swedish people. So for example, if we were interested of a population mean, then the sample mean yields an estimate of a population mean based on the samples that you draw. And now here come two really important concepts in statistics. So the first one is called law of large numbers, and the second is called central limit theorem. So now if, for example, we would like to know the mean of wages of Swedish people, then we would know that. So the problem with small sample sizes is that the small samples give less precise estimates than large samples. So actually it's quite straightforward. So for example, if you only ask one people about his wage and then use the result of this individual to guess the true means of wage Sweden, then it of course will be quite biased. So this is generally the problems when you try to know about the population by small sample sizes. However, it's quite important to know that the large numbers itself uh, does not guarantee that the generalization will be correct. So for the law of large numbers and central limit theorem to hold, the most important condition is called independent and identically random variables. So which means that each random variable has the same probability distribution and all are mutually independent. So actually it's just the same as what we said maybe a few minutes before we started teaching startup. So for example, you would like to know the average wage of Swedish people, then the probability of me being selected should be the same as probability of you being selected. And also the probability of me selected should not affect the probability of you being selected. So if this is the case, and um, and the person who would like to know this information accumulates big enough samples, then he can draw a quite credible conclusion about the average wage of the whole Swedish population from the samples that he created. So the law of large numbers states that if n is large and observations are identically and independently distributed, then the sample mean will converge to the true means. So the law of large numbers talks about the average means itself. And the central limit theorem says that the distribution of the sample will be well approximated by a normal distribution with the true mean, with the standard deviation, with the variation divided by the number of observations. So actually this one is how we create, is directly related to how we create a 95% confidence interval. And also directly related how we calculate the standard error in the startup just before. So that's why we use the standard, the variation divided by the numbers of observations here. So these slides basically summarize the contents of law of large numbers and also central limit theorem. And then the last small part is about standardizing variables. So why we standardize variables? So the first reason is that we would like to make interpretation of results easier or more sensible. So for example, we would like to know whether the smaller classes will help the students improve their grades. And there are many research about this topic across different countries. But since many countries have different grading system, so to make interpretation of results easier, then we need to standardize variables. Otherwise, we cannot directly compare the results under different grading system. And the second one is to simplify hypothesis testing. So to standardize variable, so what we need to do is that we use the value of variable minus its means and then divided the standard deviation. Then we can get the standardization of that variables. And now let's go back to Stata to see how we standardize the variables. So now in the standardization part, we use a different data set called LNU. So when we execute it, the use command with clear, it will clear the past data set that we use. And then just following the way of standardization given in the slides. So first, we create the mean variable, and then we create the standardization variable. And further, we use the school variable minus the mean of school, and then divided by the standard deviation of school to get the standardized variable of schooling. So if we execute the command, and then summarize the standardization, the result of standardization of schooling. And you can see that actually there is an interesting phenomenon. So the mean of the standardized variable should be 0. And the standard deviation of the standardized variable is 1. So this is how we do the standardization with the help of Stata. And now we are going back to the slides. So as you can see, this is the final part of today's seminar. And basically, I finished all the things that I would like to say in today's seminar. So if you have any further questions, just feel free to email me or to ask questions in Zoom. So thank you very much.